Okay, so we're going to go ahead and get started now. First off, I'd like to thank everybody for taking the time today to attend the Preferred Strategies webinar on JD Edwards Data Warehousing. That'd be a quick launch for JD Edwards. A couple of things. The GoToMeeting control panel that's taking up part of your screen, you should be able to minimize that. I think the little white arrow in the red box will minimize that to the side of your screen. And then also, as we walk through the presentation today, if you have questions along the way, just go ahead and post those in the Q&A panel or the questions panel of the GoToMeeting. You may have to open it to get it back, and then we'll tackle those at the end. My name is Adam Krieger. I'm the founder of Preferred Strategies, and I'll be walking through today's session. So thanks again for your time and joining us today. The agenda, we're going to start by just going over a little overview of Preferred Strategies and some of the JD Edwards data model complexities, and kind of cover the purpose of the data warehouse, where it fits, and the type of profile of company where the data warehouse may make the most sense. Kind of talk about some of the different layers of business intelligence and how that relates to the data warehouse. Kind of get a little overview of our data warehouse structure, and then do some live demonstration. We'll kind of cover a few things hands-on, and then come back and address some questions at the end. So Preferred Strategies, we've been working in the business intelligence and reporting space as a company since 2002. Our sole focus has been around the back end of JD Edwards. So that's kind of our sweet spot, is taking reporting and BI solutions tailored for JD Edwards specifically. We started out around Crystal reports and helping JD Edwards customers learn how to write Crystal reports, and branched into the full suite of BusinessObjects offerings. And then over the last few years, we've expanded into the worlds of Microsoft BI and Oracle BI. So I think if you kind of add the three softwares, BI market share between Oracle and BusinessObjects and Microsoft, that's probably 60+% of the market or so is probably close to that is what that would make up. So those are the key players that we work with. Those are definitely the market leaders. Our sweet spot historically as well has been able to deliver real-time direct connect solutions right at the natural schema of JD Edwards, and just pulling whatever's in the transaction system. So if you finance posted journal entry and wanted to get immediate response and a trial balance of what's there in the system, everything reflects exactly what's in JDE. With data warehouse, there is no real-time data warehousing. There's always going to be some latency between the source transaction system and the target data warehouse database. So there's near real-time, where you can kind of, as data is changing in the transaction system, we'll talk a little bit about this later on, and it's feeding over and trickling into the data warehouse, but there will be, obviously some lag there. So, so we'll kind of cover in the demo some of the different things we do from an ETL perspective: extract, transform, and load, which is the data warehouse terminology to kind of feed from a source to a target data warehouse. Again, outside of even with data warehousing, as well as just BI and reporting in general, we provide consulting services and training services to help customers get up to speed and self-sufficient very quickly. So what are some of the data model complexities that some companies or vendors as well as companies have deciphered that they need a data warehouse to resolve? And there's thousands of tables in JD Edwards. So identifying which of the different tables apply to which different modules, the naming conventions, F0006 is the business unit master, GBOBJ the name of the object account field, the dates are stored in a Julian format, and then the amounts and units are stored without decimals. Building time-based calculations like month-to-date, year-to-date, quarter-to-date, inception-to-date, actuals, budgets, variance, amounts, units. All of those are calculations that have to take place for reporting, but they're not stored in the database that way. So that's kind of where the reporting and BI tools come into play, is kind of giving you a layer to model and build some of that functionality in. So based on, let's say, a user prompt for date or year and period, it'll actually go calculate what the true quarter date or year date or month date values are. And then just some of the data stored across the different modules of JD Edwards aren't always the same. So what may be a numeric value in one table may be a text in another. The meaning of the same value is just not stored all across the board. So there's some cleanup that needs to be done to make it all work together. So these are just some of the challenges that pretty much every JD Edwards customers face, and which lead to the need for something either like a data warehouse or some other reporting or BI solution. So we kind of look at it, there's really a few different approaches to business intelligence. We're putting here like a direct connect, an ODS, and data warehouse. What we refer to here as a direct connect is really we're connecting your BI tool directly to the transaction data. Okay, so in that regard, that is a source of information that's being reported from a BI standpoint, and whatever's in the system is what's reflected in the reports. So that's kind of more of a direct connect. ODS would be if you're feeding data out of your transaction system to a repository for reporting or BI, or replicating data, and you're actually reporting against that replicated environment, or in some cases of a data warehouse, or maybe a staged environment of a data warehouse. That's what we refer to as more of like the ODS. And then the data warehouse is where you're actually taking the natural schema of a source like JD Edwards and you're modeling it into true data warehouse, let's say a star schema, or depending upon your technique, that's kind of the most common. So that's kind of where you're restructuring some of the data in the feed. So that's where you're transforming it along the way, where the ODS is most likely not highly transformed, where the data warehouse would be highly transformed. They each have benefits and challenges. Obviously, the benefit of direct is it's all real time. It is, of all the three approaches, the least reliant on IT and probably the lowest total cost of ownership. Really, why not do direct? In most cases, it may be a company policy, or maybe you have multiple ERPs that need to be reported on at a consolidated level together. So that makes that a little more complex to address that way. From an ODS perspective, the benefit of that is you can just offload reporting with near real-time data. So it wouldn't be as great as having real-time data, but you can get close to that. That's not going to solve the challenge of necessarily tightly integrating data across different systems, where that's where the data warehouse may come in and add value there. So I think where the data warehouse makes the most sense is if you have data that needs to be tightly integrated across various systems. That's where modeling that data for a BI and analytic perspective makes a lot of sense. However, the downside of that is obviously the impact and reliance it does have on a technical nature for your IT staff. So I'm going to reiterate some of these over the next few slides as well. What's the purpose of the data warehouse? I think a lot of companies, they aren't happy with the getting out of JD Edwards reporting out of the box, so they figured, I need a data warehouse, and that's going to solve all my challenges. And I think what most companies don't realize is that in a lot of cases, just adding a data warehouse to the mix potentially could be adding more challenges than existed before. So I think that for advice to companies would be, before you kind of get down the path of, do I need a data warehouse, do I not, is just what problem are you trying to solve? And I think most customers are just trying to empower end users, get reporting out of the hands of IT, get the ad hoc, get analytics in the hands of the analysts and the users and the business, so they can make their own decision based on the data and build their own content based on what's in a source like JD Edwards. And then, again, maybe if there's different companies have different sources of data, and from a financial perspective, is all your financial data sitting in one source like JD Edwards, or is there JD Edwards and Great Plains and SAP and PeopleSoft, and you need to blend it all together? And that's kind of what you need to analyze and evaluate your current environment to determine where the data warehouse may fit. And the other thing is identifying your company technical profile. What we mean by that is, as it relates to reporting and BI, what's your internal skill set, and how many IT staff members do you have that are actually going to be focused on reporting and BI? How many instances of JD Edwards? Are they all in the same different versions? Are they on different versions? Or World and EnterpriseOne? What's that look like from a number of instances of JD Edwards? Number of systems that need to be integrated with JD Edwards, and budget. And based on kind of evaluating that, we'd be happy to dive into these details with you. I think you can kind of come away with a better understanding of whether or not the data warehouse may be a good option for you or not. But you know, regardless of that, it's good to understand the different layers, and we're kind of summarizing this into kind of 3 layers of business intelligence: the back end, the semantic layer, and the front end. And so the back end is really where does the data reside. That's to me the source of the analytics. And so the back end, again, the 3 options that we mentioned before: a direct connect, a replicated environment, or ODS, and data warehouse. And the semantic layer is kind of the area where you're going to be modeling the data. You're creating the relationships. You're building that layer that really the end users are exposed to. So regardless if you go direct connect or replicated environment or data warehouse, the whole concept of a semantic layer or metadata layer is where you're translating any content into a usable format for the business. That's a requirement either way. So just because you have a data warehouse doesn't mean you can skip that layer. You still are going to be modeling in that semantic layer. And then the front end is kind of where, based on the software that you're implementing, there might be different options at your disposal. But this is where the reporting tools and ad hoc query and Office integration tools and dashboards and BI mobile type stuff, these different options may be available based on, again, what you're exploring. But the key difference here, if you look at that semantic layer, direct connect, because the data is not structured always in the easiest way for end users to analyze, you need to do some legwork there, and that takes place in that semantic layer. So there might be more business logic going on in that middle layer under a direct connect, and the same for replicated, because the replicated environment is very, again, hasn't gone through all the transforms of a full-blown star schema data warehouse. So again, that middle layer would be required to deliver more business logic. And the data warehouse, since you're pushing out back to the data and the transforms to some degree, that might be a little less complicated in the semantic layer. So this is just if you're kind of building all this from scratch, this is really good to know. If you're buying it, it may not be a big deal if there's the semantic layer is a little bit more complex in one versus the other. So another view of that, again, if you had your J.D. Edwards data as your source, again, you're going to have the semantic layer connecting from that and then feeding the end user. Where if you're replicating data, J.D. Edwards is feeding to, in essence, another reporting repository. That's fed into the semantic layer. Now you'll notice here that we've got both, and I think for most companies that go down the path of an ODS or a data warehouse, unless it's a company policy to not do anything direct, this is kind of where a hybrid type solution I think makes the most sense, because there may be certain modules where real-time is a requirement and near real-time just won't cut it, or even the volumes, let's say, or just there's just no reason to spend the effort to model the data for some JD modules. So you go to the data warehouse again. Now you're kind of feeding from J.D. Edwards potentially to like a staging area, and then into a warehouse, and then again any one of those 3 could feed the semantic layer. And the end user. So, and our argument is that the whole key of the semantic layer is where you're transforming and translating it into a usable format for the business. So if I'm a user building a report, at least with preferred strategies, BI quick launch content, I wouldn't be getting a different end user experience if I was pulling a report against the data warehouse or the direct connect, because that middle layer looks the same either way. So that's good to know that, again, just the data warehouse doesn't mean that the end user experience is going to be different. So if you look at the different support of the data warehouse, direct connect, let's say, versus the data warehouse, again, as I just mentioned, the end user experience would be pretty much the same. The semantic layer complexity obviously is going to be a little bit more stuff going on in a direct scenario than the data warehouse. However, though, the direct is real time, and the best the data warehouse could be would be near real time, or some type of hourly, nightly process depending upon the requirements. IT involvement, once the direct solution is set up, it doesn't really require much maintenance because it's connecting right at the source. There's not these extra layers that you need to be thinking about in the process to feed data to these other, the target for the data warehouse. So when those go down and that data warehouse isn't being updated to, the frequency it needs to be, or, one of those pieces stops working at one point and it needs to be troubleshot, then that's where, it's going to take IT involvement to get that back up and running. Again, the multi-data source, with the direct, you could actually theoretically do direct against all sources. However, if those need to be tightly integrated together, then that can be more complicated in a direct approach where, the data warehouse, and this is kind of where the hybrid approach, where you need tight integration across systems. It's easier to do with the data warehouse, or at least with the data, regardless if you go down the full star schema warehouse approach or not. From a query performance standpoint, at least for the typical JD Edwards customer, I'm not sure that the expected gains of a data warehouse are really there. I think we've seen with our direct approach compared to data warehousing content, it's pretty much by all means comparable one or the other, and sometimes the direct seems faster, sometimes the data warehouse may be faster, but that's not always the case. That you might assume that it's always going to be better against data warehouse. That's not necessarily always the case. From a cost perspective, obviously you're adding pieces to the total pie here, and by doing that, obviously there's going to be costs from a hardware, from a potentially if you had to buy pre-built data warehousing, but also just from a total cost of ownership. Again, there's more IT resources that are going to have to support that than a direct approach. Do I need a data warehouse? Again, back to just to reiterate, and then there's the last slide, we're going to focus on this. If you have experienced deep IT staff related to data warehousing, ETL, you have that knowledge and that domain experience, then I think then it definitely makes more sense than if you don't. You have multiple instances of JD Edwards. You need to integrate non-JD Edwards and JD Edwards, extremely large volumes, big data, and you have a fair BI budget, then I think that's something to explore. If you've got very lean, some of our customers have one or two IT people that support all applications, and so to add this to the mix of a data warehouse just really isn't in the cards. If you have one instance of JD Edwards, you've got want some quick wins, and you've got accelerated timeframes to get things in the hands of users, then that's not really where the data warehouse would make the most sense. And if you're obviously have lean budgets related to BI, things to consider either way: impact of transactional processing, with the performance, integration of data. But these are all things that can be either tested and kind of validated on just running something direct versus a data warehouse. So now, since I've probably put a lot of question, people might be, why am I so opposed to a data warehouse? And I don't want to come off as opposed to a data warehouse, as we sell a data warehouse for JD Edwards. I just want to be completely transparent that it's just not the right fit for every organization. When it is the right fit, by all means, model data. I think the big wrench that's been thrown into the mix over the last couple years has been the whole concept of in-memory computing and in-memory databases, where now the message is, well, you don't need to do all that transform to model data because now hardware is solving the problem. So you can go ahead and just throw the data in a in-memory database, and voila, your problems are solved. You don't have to worry about modeling into a Ralph Kimball star schema type thing. So the question is, if that were the case, then if it's all about performance, then what if performance is good even without an in-memory database and without a data warehouse? So what is the true objective that you're aiming at? But so we talk about now, we're going to spend the rest of our session kind of focused around, if you're going down the path of the data warehouse, what's the approach that we've taken? What can we do to jumpstart it? And that's what we're going to kind of focus on the next few minutes here in the presentation. So for our data warehouse, again, we're kind of following the Ralph Kimball, so the star schema. So we're kind of modeling the data from JD Edwards into that star schema. We've got various types of fact tables that are being built out as part of the warehouse. From a dimension standpoint, we've got conformed dimensions that are, conformed dimensions. In essence, you're creating a business unit dimension or account dimension or an address book dimension that's kind of shared across modules. And so that's what we're building out. So you'll be able to share a lot of the logic. So rather than kind of more about like a MART type approach, it's kind of more of like an enterprise data warehouse approach where, again, you've got these ability to have these conformed dimensions, storing the data in one place, and it's shared across the various modules. From reporting and BI, building out time dimensions that provide you all the extra logic to build out the stuff you need from a reporting perspective, as part of the package as well. Cleansing of fields, surrogate keys. We'll kind of point out some of these as we get to the live demo in a minute. And just kind of lay it out there. So these conformed dimensions, again, that's the value of if you're going to go down that route, rather than just keeping the same copies of the data in all these other databases, kind of keeping it into one target. And so what we kind of put in here, just to give you a flavor of some of the different JD Edwards modules and what are the how the conformed dimensions might be scattered across those different modules, and at least from our perspective. So it kind of gives you a little bit of a sense. So now, from a live demonstration perspective, we're actually going to start by getting in, and so what we've done is for a lot of our core data warehouse content, Microsoft SSIS has kind of been the go-to ETL tool. Again, extract, transform, and load software to get data from JD Edwards and feed it into a data warehouse. So we're going to open that up and walk through a couple different loads to kind of explain what's going on in the process, how data is moving, and what's kind of happening to that data throughout that. So we'll start looking at just some of the CAN structure there. I'm going to give you a couple of examples of some facts and dimensions. And then again, like I said, we'll run through a full load, and then a CDC load, which stands for Change Data Capture, where it's actually not going a full load. In essence, is grabbing everything from your source and feeding everything to a target. So the very first load that you do would be a full load. And then after that, if you're kind of using more of a change data capture, is that you're just tracking the changes that occur, and then those changes are brought over and updating the data warehouse rather than doing fulls every night. Okay, and that's what that is. And we'll kind of speak to that a little bit more in the live demo. We'll also show an example of taking JD Edwards sales data and using BusinessObjects Data Services, feed data over into their in-memory computing platform called HANA, and kind of show you a sales model there for HANA. And then we'll kind of show you, again, these are all back-end things, but we'll then just show you an example of like a semantic layer for business objects and Microsoft, where then you're still kind of creating those relationships and modeling the data in that metadata layer. Okay, so I'm going to go ahead and flip to a different screen here. So the first thing I want to do is we're going to go in here, and I'm going to pull up, and on the left-hand side you'll see here we've got a list of these different objects. So we've got dims and facts, and these are kind of the different dimension objects and facts that are associated with the sample warehouse on, let's say, for General Ledger. So if I go in here and open up and look at the columns here, you can kind of see the column naming conventions that are here. And if we wanted to kind of just get a sense, I'm going to go ahead and pull the business unit. We'll focus on the business unit dimension to start as we go through the ETL. I'm going to go ahead and just do a select on that. So right now I've got no data. So in essence, we've truncated the target. There's no data there. So if we want to populate this the very first run, we do a full load. So if we go open up the SQL Server data tools and look at the ETL for that, I'm going to go ahead and on the right-hand side open up this full load. Again, this is something where who owns this. And again, you can buy this from Preferred Strategies, but if you even if you buy it, the goal should really be to have your internal resources be able to maintain it and update it. And our whole point of a BI quick launch and quick start is to give you a foundation to build from. And so we're just kind of jump starting you in the process. and we try to follow all the best practices along the way. So one of the things here, if I look at this full load process, there's this, because after the full load's completed, there's going to be this change data capture process to populate and update the data in the data warehouse. We need to basically tell that, hey, I'm working with the data, I'm going to update it. So we want to go out there and give it some type of timestamp for this change data capture to realize, hey, this is now being touched, so it can leverage that in later processes. As a full load, it's going to go to the target, and it's going to truncate the table. So when in a full load, we're saying we want to clear out the table that's there and reload it. Okay? So it's going to truncate the table, remove all the data in the target, do a full load, grab everything from the source, and feed it into the target. After it's completed, it's going to come back here and say, okay, I'm going to update, saying I'm done. I'm going to go ahead and notify it that I'm done grabbing the data. And so at this point, it's now everything's reflected. And then it's going to go in here, in this case, because the business unit dimension, we've got all the business unit category codes and the other user-defined codes that need to be associated with that dimension that need to be created. And the last step here, we actually go in and insert a blank row. And the main reason for that is just a best practice to have every value of every dimension have a blank row in it. So in essence, it's flagging it with like a -1 value. So you can do inner joins across everything, and you don't have to worry about doing left outer joins and potentially losing data. That's really the benefit of that. So if we go up here and just run this, you'll see it's going to go ahead and update. Once it's done, it's actually now generating the cat codes. It says the package completed successfully. We'll go ahead and stop that. Let's go back to the data. So we just ran a select on this and pulled everything, and there was no data in there. Now we've just done a full load. So let's go ahead and execute that again, and now we've got, in essence, that business unit dimension on the left-hand side. Again, this is what we're looking at, is what we're seeing here. So we've got, the first code, or the first column here is a surrogate key. So if you're following kind of Ralph Kimball kind of best practices, the surrogate key is you're creating, outside of what the key is in the system, you're creating a numerical key that's unique for every value, and in essence, that'll be associated with each dimension table, and that will also be the key that's actually within each of the fact tables, and that's basically the surrogate key is how you're creating the relationship between a fact and a dimension. And if you're not familiar with the fact versus dimension, the fact are the core tables that are storing the data. So all your amounts and units and metrics may be in that fact table, and you'll have, based on the different dimensions that you need to slice and dice by business unit, by account, by company, by different category codes, those are the things that you can be relating, to the dimension table. So another thing you'll notice here, we've got the business unit kind of cleaned up, trimmed, where you see the business unit native has some spaces in front of it. Kind of scroll to the right, we've got business unit type, and then if we keep scrolling, you might have some other values there, contract types, different dates. So again, this is a conformed dimension, so it's going to work for general ledger, it's going to work for job costs, it's going to work for sales and inventory. So again, it's kind of got the support to have a variety of uses rather than just for one specific module. And we're not copying the same table and putting it in different marts per se. If we want to look at another example here, this is a look like the account dimension. And a couple of other things to point out. You'll notice something very similar here. We've got the surrogate key, and then we've got, here's in essence the account ID in the system. The account description. If we scroll to the right here, we're also getting just the pure object description. So this is actually pulling back the unique description associated with each object account. And I go further to the right, we've got now the subsidiary description. Okay, so that's one thing is, if you think about like in GL versus job cost, you've got the account, and the roll-up of an account in a general ledger is the business unit.object.sub. Okay, so that's what you see here, like business unit.object.subsidiary. Well, in job cost, it actually is a little bit reversed. So the actually roll-up from a job cost perspective is the business unit, the subsidiary, referred to as a cost code, and then the object account, which is the cost type. So that's kind of where, again, it's building in the logic to make the different scenarios that you need for the various types of reporting. So, and then as we go to the right here as well, you've got the different, category codes. So that just kind of gives you a sense. let's go ahead and take a look at a change data capture load. So that was a full load that we did. If we want to go back, let me close out of that, and we'll open up for the same business unit, let's say a change data capture. So now in this scenario, we've got, let's say, a full load. And so, on an ongoing basis, with a change data capture, we're pulling in from, the journals or the logs, or, so you're getting data, kind of tracking just the change of data. So we're not having to go in and say, what's the data, for the last, 5 years or whatever, repopulating, dropping, truncating, and doing fulls every time. It's just a matter of, in the databases, you can identify the changes, whether or not it's an insert, an update, or delete, and based on that, that'll kind of trickle into the process, and we'll manage it a little bit differently. So the first thing when this process runs, when we execute this, it's going to go back and say, okay, I'm starting a change data capture process. So I need to go back and identify when that was ended from the full, and that's going to give me my my essence, my starting point, and going to be used for just tracking the different states of that process. We're going to go into the staging table, so because we're going to grab from those changes and update a staging area that stores those changes. So we're going to truncate the staging so the staging is clear. We're going to update that staging with what's in the system, and that's going to feed a couple of different things. If there are any changes, then it'll actually trickle everything right down here to the end result. Okay, it's going to update the target table. It's not going to make any updates because there's no updates to be made. Whereas if we go in here and the data flow, again, as it goes through, it's going to go through a splitter. There'll be either inserts, deletes, or updates. And in essence, so based on what gets an insert, so all the inserts and updates will go through this process, and then it'll go identify those, bring them in, and then any category codes that need to be identified, excuse me, would actually be generated on that data and then merged back with the target. Okay, so now that target's updated with that, and then we go through any deletes that need to be removed from the target, go through and get removed. In essence, then at the end of the process, it'll update and say, okay, we're done with this change data capture. Let's update that timestamp, and it's done. Okay, so again, just like we can run this, if there aren't any changes, everything's just going to kind of trickle down. In this case, again, I didn't make any changes to the source or target, so everything was probably just flowing right to the left. Until at the end it's complete. Now, so the way this works is that you kind of get these going on, the different schedules and based on the frequency that you want to be updating the data. Sometimes you have options. You can run it at very quick intervals, and sometimes based on volumes and latency, you may be forced to put that on a bigger lapse of time. Again, every company is different. So again, that's in a nutshell, the building of the data. So in essence, that's the data warehouse. We're no longer using, or in our case, we'd still recommend a hybrid where you're potentially reporting on direct as well as the warehouse, both when applicable based on the requirement. But so what does that look like? So we've got this data. In essence, that data warehouse is just a series of fact and dimension tables. So, the question is, I've got all this data, it's now transformed, it's now in a business user format, however, it's not related still. So now instead of having to figure out which thousands of tables I need in JDE, you're now down to which of these 20 or 50 tables do I need to basically create the model. And that's kind of where, if we go ahead and I'm going to flip over here to we'll give you a couple examples here. So we're looking at on this screen is like an example of, let's say, like a general ledger, our general ledger universe. That's our direct universe. This is in essence what our universe. Now, what you see here on the right is the relationships of all the tables and views and everything that go connect to the transaction data. What's on the left, in essence, is all the fields and the calculations that have already been defined in the semantic layer. Okay, so on the left is the only thing that the business sees. They don't really get exposed to what's on the right. They just get exposed. So what we've done is gone in here and we provide descriptions for every field. Get down here to amounts and units, and this is kind of where we're building in those calculations If we were actually pulling up like our universe on top of like the balances, that's where we've got all the things for current year, year-to-date, month-to-date, quarter-to-date, and all of that. So this is kind of the universe where you define all of that. So the difference really is between this universe or the data warehouse is if I go ahead, you notice we're getting to a true star. So what's the difference between a star schema and a snowflake? Okay, so you notice here the star schema, you've got a fact table, and there's a join. These are all inner joins to the dimension tables. Okay, so these are the dimension tables that are associated with that specific fact for the specific module, where if you go back to the other, it's a snowflake. We're linking from this, in essence, let's call it a fact, even though it's not a data warehouse fact table, it's J.D. Edwards general ledger table, linked to the business unit master that's then linked into snowflaked out to get, let's say, the user defined codes. Right, so it's that other relationship that comes into play. At the end of the day, all those values have been identified and are available for the end users. Right, it's just a matter of what SQL is taking place when they run that. But that's the beauty of the data warehouse, is you can simplify the semantic layer, and however you're simplifying that from the back end per se, with the assumption that expectation that they're keeping that up and fully running all the time is something that IT is going to be responsible for. But on the left, it's the same end user experience. So the users, wouldn't necessarily know the difference whether or not something there is going as a data warehouse or direct in our case. Same thing on, let's say, we'll pull up an example in, let's say, Power Pivot. Okay, so and this is a model we actually map to the data warehouse in Power Pivot. Again, we're establishing those relationships in Power Pivot, and then the end users, could basically, but again, if I'm looking at this, it's the same that I'm going to get if I'm in, end user building a report off of, because we're building that layer either way. So we'll go ahead, for the sake of time, we'll go ahead and not kind of dive in. If you're interested in seeing any product demos, we did do other webinars for the Business Objects and Crystal, Microsoft Power Pivot, and Oracle BI Publisher. So those YouTube clips will be available on our website, and so you can kind of view those, where you can kind of get a more of what the end user experience might be. I think we wanted to show in demo was, or just kind of point out a couple things. So we talk about the the in-memory type computing, in-memory platforms. So if I go here, opening up, let's say, Data Services as an example, this is Business Objects ETL. And so what we've done here, an example on the sales side, is showing based on the different dimensions and facts associated with sales, using, instead of SSIS in this example, we're showing using Data Services, we're feeding that data to the SAP HANA database. And in essence, it's in the HANA where you can then model the data. Okay, so the difference here is that within HANA, so this is kind of the feed, and that's what we're using the data services for, as it's SAP's ETL tool and it's SAP's database. That's where the integration is there to be able to use this to feed that target. We'll go ahead and look at an example. Oops, let me pull this up. So you'll notice here, we're actually feeding into this, and I go here to look at like the tables. In essence, we're feeding the HANA database with a set of tables, okay? And then within the HANA modeling, you can actually model and create what are referred to as attribute views, and that's kind of for your different dimensions. You'll create what are referred to as attribute views. And then there's analytic views. In this case, we've got, let's say, a sales analytic view, which is actually shown here on the right. So with an example of sales, you might be looking at your different sales detail, your headers. So you're basically creating this data foundation of kind of the factual information, and then you're relating that based on what you need to all the different dimensions that are associated with that. Okay, and that's what's kind of in the logical joins here. So you're modeling the data for this high performance deliverable, and you're kind of just creating the semantics where you're kind of giving it and renaming things how you want, but that's kind of already been done in the process to get to this point. So this is an example of how you can even model the data in like an in-memory database and then what does a universe look like on that. So if you're actually modeling here, you're kind of already identifying these relationships and creating an output that's covering across all the dimensions that you need. So getting the address or the customer dimension and the the item dimensions and the business unit dimensions and all the other related dimensions that are associated with sales rep and whatnot. So you're kind of getting all that. So let me go back to the other screen and we'll show you an example of like a universe on top of that. The business objects universe is in essence the semantic layer. Oops, wrong one. So if we go here and take a look at like a sales example, because we've modeled that behind the scenes, again, on the left-hand side is what the users see. So this is the same regardless of whether or not someone's doing data warehouse or not, but on the right-hand side, we're actually just bringing in one table. So you kind of get rid of all those joins. That's all fed back to the modeling on the HANA side. And then, in essence, you've got the universes that are referring to the objects from that. So that kind of gives a little bit of a flavor. We can open it up, I think. And we'd be happy to do is, if you think that the data warehouse is of interest, I'd highly recommend let's connect and we can kind of do something more one-off for your organization and take a deeper dive if there's questions about our approach.